New chapters, section 511. We're going to be taking a look at inverses and logarithms in this entire chapter. In this section, we're going to kind of talk about this idea of undoing equation and how it's going to fit into this idea of finding the inverse of a function. And so by the end of this lesson, you guys are going to be able to understand what it means to undo an equation, verify if two equations are inverses of each other, and how to find the inverse of equation. Now in all of my lessons, just reminder, blue, if you see like the title or something inside here that's highlighted in blue, that's something you should write down in your notes. Gold means you should probably put that in your notes and create a flashcard of it, because that's something that you're going to want to remember. And so having that stack of flashcards going over those definitions and theorems, that's going to help you in the long run. So what does it mean to undo equation? So later in this lesson, you're going to see why we're going to do this exercise and why this exercise is important. And you're actually going to see in future lessons why this idea of undoing an equation is going to be really, really important. So first, let's kind of start this with an exercise. So I have a number that I'm thinking of. Now, I want you to add 5 to my number and then multiply that result by 4. You're going to end up getting 40. Now, what is my number? Now, I want you to kind of sit there and think about it, pause the video, and see if there are a few ways that you can go through and figure out what that number is. So please pause the video here and determine what that number is. All right, so let's talk about that. So I said when you add 5 to my number, then multiply the result by 4, you get 40. What's my number? So I have some number in my head, and I said when you add 5 to that number and then multiply that by 4, you get 40. So what was a way for us to figure this out? Now, a pattern that you guys should have realized is that working backwards or undoing each of those steps is going to give me my number. So I started with 40, but instead of multiplying by 4, I divided by 4. And then instead of adding by 5, I subtracted by 5. And so 5 was my original number. And so let's go through this. So if I plug in 5, 5 plus 5 is 10. 10 times 4 gave me 40. Now what you guys just did was quote-unquote undo my equation. This is essentially an inverse, and we're going to kind of see that throughout this lesson. So we undid that expression. Now if I want to rewrite what I just said, I can actually express that as a function. And so my number plus 5, all of that times 4. Well, I can actually express the whole quote-unquote undoing as a function as well. And so this equation that we see here, this is my quote-unquote undoing equation. Now let's kind of look at that. So I took my number and divided by 4, then subtracted the result by 5, and I ended up with my original number. Now we call this new function my inverse function. And so if you notice, this says f of x. Well, this still kind of said f of x here. The difference is that it has this little -1 as an exponent. It's not an exponent. It looks like it, but it's not an exponent. That literally means that these two functions are related and they're inverses of each other. They undo each other. And so I really want to emphasize that. When you see this notation, it is red, f inverse. That -1 is not an exponent. Do not misinterpret that -1 as a negative exponent, meaning this does not mean this. It's easy to get that confused. You will never see any notation next to like a function like this and anywhere else. This literally means that this is an inverse of that function. Now, because we just said that inverse functions undo each other, what that means, and this is, now we're getting technical here, so this is something that we want to add to our flashcard, that if I take a composition of my two functions, they will always simplify to x, no matter if I plug my f into my g or if I plug my g into my f. Remember, composition of functions means you take that function and you plug it into the other one. So if you take that composition and you plug it in, they're going to simplify it down to x. And if you can show that, then you know that they're going to be inverses of each other. So essentially, to verify if two functions are inverses of each other, if you take the composition and they simplify to x, they're inverses. It also implies here the domain and ranges switch when you have inverse functions. We're going to see why here in a second. So if I wanted to verify, are my two functions inverses, right? I gave you two functions, bam, and you have to determine, are they going to be inverses of each other? Well, you want to do this composition. So the first one, g of f of x, I'm going to take my f function and plug it into my g. And then you want to simplify it. Well, the 6 and the negative 6 are going to cancel out. Oh, look at the 3 and the 3 are going to cancel out, and I get x. Great, I showed it. So now I want to do the same thing to the other one. So you take your g function and you're going to plug that into your f. So I'm going to take my g function and I'm going to plug that into my f function. And so 3 times my g function plus 6. Well, the 3's are going to cancel out. The negative 6 and the positive 6 are going to cancel out, and I'm going to be left with x. So because I showed both of these functions, g of f of x and then f of g of x, right? I showed both of those compositions and they both equaled x. I can now conclude these are inverses of each other. Now, if in one of these situations they were not x, then I would say they are not inverses of each other. So let's show another one. The first one, g of f of x, meaning I take my f function and I plug it into my g. So I take my f function and I'm going to plug it into my g function. So instead of x, it's now x squared plus 3. Well, the 3's cancel out. And then square root and the square cancel out, and I'm left with x. Now the next one. Take my g function and plug it in for f. So I take my g function and I plug it into f. Well, the square root and the square are going to cancel out. And then negative 3 and positive 3 cancel out, and I get x. Well, I showed equals x equals x. Therefore, I can conclude these are going to be inverses of each other. Now, one thing I just want to point out. Okay, it's blue. This is something that you're going to want to get down. Now, if you want to get both examples down, sure, but one example is good enough. So now we're going to find the inverse of our function algebraically. Now, if you remember that definition that I had you write down, one of those implications there was that your domain and your range, and you're going to switch. Now, we're going to talk about that a little bit more in tomorrow's lesson, but I just wanted to throw that out there to kind of help us out a little bit. So our domain and ranges, they're going to switch. Now, what that means, your domain were your x values and your range were your y values. So if our domain and range switch, when we want to find the inverse function, what we're going to do is we're actually going to take my y and my x and we're going to switch them. That's the definition. Once you do that, all you have to do is solve for y. Get y by itself, and the equation that you have is going to represent the function of an inverse. So then I'm going to add 5 to both sides, and I get this. Well, y is not by itself, so divide both sides by 2. And so I'm going to end up getting this. Now this equation here, that is going to be my inverse function. So to repeat what I did, to find your inverse function, the first thing you're going to do is you're going to switch the x and y value. So you're going to switch them. There's your y, there's your x, and I switched them. Then I solve for y. So I got y by itself, and because this is still a function, I was able to use this notation. Now, if there is a moment in which this is not a function, then you cannot use this notation, and we'll kind of talk about that in class, and we'll see examples of that in the future. So on this one, find the inverse of the function. So the first step, I'm going to switch the x and y. So instead of y equals 2x cubed, x equals 2y cubed. And then that plus 3 is still there. Now I need to solve for y, so get y by itself. So the first thing is subtract 3 on both sides. Then to do the cube root here, I first have to get rid of the 2, so divide both sides by 2. Then now I can cube root to both sides. And then this is still a function, so I can use my function notation. Now I want you guys to practice a few of these. So go ahead and practice finding the inverse here, and then go ahead and pause it while you work on it, and then you can take a look at the work. It's going to all appear all at once. So go ahead and pause it, and then the work is going to show. Let's look at another one. So I want you guys to go ahead and try this one, pause it, and then the work is going to show. Alright, so what did we learn here today? Well, we talked about undoing a function, and that kind of meant that whenever a function is constructed, you're kind of working in the opposite direction to find whatever it is that we need to find. Now that undoing function, we formally call that an inverse function. And so what we said was one of the definitions of an inverse is if we find the composition, or g of f of x, right? Because these functions undo each other, we're only going to end up with x. Okay, and so that inverse function is the quote-unquote undoing function. And the way that we find the inverse of the function is we start whatever our equation is, or our function, because when we find the inverse, the domain and range switch. We're going to switch the x and y's, and then we're going to try and get y by itself. This does conclude our lesson. If you have any questions, please leave them in the comments.